back. Now we look at levels of measurement: nominal, ordinal, interval, ratio. We have categorized data as either qualitative or quantitative. Remember, quantity is what you can add, average, and so on. Quality is simply category, right? Now, another way to classify data is according to one of the four levels of measurement. These levels indicate the type of arithmetic that is appropriate for the data, okay, such as ordering, or taking differences, or taking ratios. All right, let's see what they mean. Okay, now the nominal level of measurement applies to data that consists of names, hence the word nominal. Nominal pertains to names, labels, or categories. Okay, there are no implied criteria by which data can be ordered from smallest to largest. For instance, if I say look at people who have climbed Mount Everest, separate them into categories of male and female, that would be simply nominal, because we don't assume any one gender is better than the other. Likewise, you could separate, categorize all these mountaineers who have climbed Mount Everest according to their nationality. That is also nominal because it's simply a name of the nation. We cannot presume that one nation is better than the other, and so on and so forth. There is no order involved, okay, no ranking involved, simply categorizing people. So that is nominal level of measurement. Whereas the ordinal level of measurement applies to data that can be arranged in order. So you want an ordinal. However, differences between data values cannot be determined or are meaningless. So, um, for example, if you're studying the same mountaineers, and ask them to give category, was it easy, hard, very hard? Okay. Now each mountaineer will give you one of these three categories. Okay. So easy, hard, very hard. Now there is an order here. Okay. You know what is more than the other, and so on and so forth. Okay. Or if you ask people, hey, interview people and ask them to say whether their boss is, um, rank your boss from say 0 to 5, 5 being excellent and 0 being worst. Well, these are numbers, but it doesn't make sense to say 2.5 or 2.2. You would say 0, 1, 2, 3. This is ordinal. So you put them in category, but those categories can be ordered. Now, the interval level of measurement applies to data that can be arranged in order. Okay. In addition, differences between data values are meaningful. For example, let's go to the mountaineers, ask them their date of birth or year of birth. Year of birth. Well, that can be ordered, all right? But moreover, it makes sense to say somebody was born in 1970 and somebody else was born in 1980. The difference means the one born in 70 is 10 years older. Okay, so the difference makes sense. So that is the interval level of measurement. The last one is Ratio level of measurement. It applies to data that can be arranged in order. In addition, both differences between data values and ratios of data values are meaningful. Data at ratio value level have a true zero. What does this mean? Say, suppose I ask the mountaineers their age in years. Okay, age 0 has a true value. It just means you're born. So, okay, you're not climbing the Mount Everest, but age equals 0 makes sense. It also makes sense to say somebody is twice as old as somebody else. Likewise, height of a person. Height 0 has a meaning. Okay, it also makes sense to say somebody is twice as tall as the other. So, ratio means 2 times, 3 times. These are examples of ratios. They make sense. So that these are the levels of measurement: nominal, ordinal, interval, and ratio. Okay. Identify the type of data. Taos, Acoma, Zuni, and Koshti are the names of 4 Native American pueblos from the population of names of all Native American pueblos in Arizona and New Mexico. What are these? These are nominal level data. They are simply names. We are not assuming one name is better than the other. By looking at the name alone, we cannot determine if one name is greater than or less than another. Any ordering of the names would be numerically meaningless. In a high school graduating class of 319 students, Jim ranked 25th, June ranked 19th, Walter ranked 10th, Julia ranked 4th. First is the highest rank. These data are at the ordinal level because these are ranks. Ordering the data clearly makes sense. Walter ranked higher than June. Jim had the lowest rank. Julia had the highest rank. Okay, Julia was 4th. Jim had 25th, and so on, right? Ranking higher than June makes sense. However, numerical differences do not have a meaning. Does it make any sense to say, hey, the difference between June and Walter is 9, whereas the difference between Jim and June is 14? No, that makes no sense because that 14 or that 9 doesn't say anything about their score or whatever, does it? Okay. So, numerical differences in these ranks do not have meaning. So, it is only ordinal. Now, for example, here is the difference between June's and Jim's ranks is 6. This is the same difference that exists between Walter's and Julia's. Okay, so they may have the same difference in their ranks, but their individual score in the exams may be different. So this difference doesn't really mean anything significant. If you looked at, say, grade point average, GPA, Walter and Julia may have had a large gap between their grade point averages. June and Jim may have had a closer GPAs. In any ranking system, it is only the relative standing that matters. Differences between ranks are meaningless. Body temperatures, say in degrees Celsius of trout in Yellowstone River. Now, we are looking at body temperatures of this particular fish, and the temperature is being measured in Celsius, so everything is technically clear. Okay? These data are at interval level. We can certainly order the data, okay, because body temperature, somebody is, one fish is warmer than the other, so you know to order it. We also know the difference. We can compute meaningful differences. However, for Celsius scale temperatures, there is not an inherent starting point. The value 0 degree may seem to be a starting point, but this value does not indicate the state of no heat. No heat is not 0 degree. Furthermore, it is not correct to say that 20 degrees is twice as hot as 10 degrees. That makes no sense. Okay, 20 twice as hot has no meaning. So this is simply interval level. Okay, ratio does not make sense. Difference makes sense. Now, suppose you are looking at the same fish, but you are now measuring the length of trout swimming in Yellowstone River. These data are at ratio level. An 18-inch trout is 3 times as long as a 6-inch trout. Observe that we can divide 6 into 18 to determine a meaningful ratio, right? It makes sense to say, hey, this particular trout is 3 times as long as that particular trout. So when you can say 3 times or 2 times, you are actually taking ratio. So this is ratio level. So how to determine the level of measurement? Well, the levels of measurement listed from lowest to highest are nominal, ordinal, interval, and ratio. To determine the level of measurement of data, state the highest level that can be justified. Okay, nominal, we can put data into categories. Ordinal, we can order the data, smallest to largest or worst to best. Each data value can be compared with another. In an interval, we can order the data and also take the differences between data values. It makes sense to compare the differences between data values. For example, we can say one data value is 5 more or 12 less than another data value. Ratio, we can order the data, take differences, also find the ratio. It makes sense to say one data value is twice as large as another. Okay. So finally, the last technical term, descriptive statistics. Descriptive statistics involves methods of organizing, picturing, and summarizing information from samples or populations. So you want descriptive statistics is where you organize, picture, summarize information. Okay, so you have collected your data, you're organizing it in some fashion. You're drawing pictures with them to discuss with your colleagues and so on and so forth. Inferential statistics involves methods of using information from a sample to draw conclusions regarding the population. So in inferential statistics, you take the information you have and now you work with it and then say something about the population. All right. So there is descriptive, you're only describing your data in various ways. All right. In inferential, you're inferring something about the population. All right. So this completes the theory on section 1.1. Next videos will cover the problems. Until then.